Hello, everyone, and welcome back to my channel, Monica Maths Classes. I also make videos for grade 9 and 10 CBSE curriculum. So, if any of your friends or relatives are in these classes, refer these videos to them because it will help them a lot to understand the concepts. So, we will begin today with our first topic in grade 8, which is chapter number 1, rational numbers in NCRT. So, try to enjoy that first and understand that how it is coming. So today we will cover in rational numbers and what are rational numbers and the different properties of it. Okay, so enjoy your learning and I hope that you will take this forward. Yeah, so let's begin. So if I ask you what are rational numbers, what could your answer be? You have not done before, right? But in grade 7, you must have done a bit of it. So if I ask you what are rational numbers, maybe you have forgot, but let's take you to rational numbers because it's actually a journey from the number system where you have begun in your primary classes. Like if I start the numbers, which your journey of learning begins with kindergarten. So you have started with counting numbers, like your learning starts at home with your mom. One, two, three, four. Yeah. So you started knowing these are called as numbers. So those numbers which comes naturally are called natural numbers. And how these numbers look like, because it starts with one, two, three, and so on. And it goes on and on. Yeah. So these are called natural numbers. Then afterwards, if you see, uh, here it is mentioned that it is one, two, three, and so on, right? So these are set of natural numbers. Then afterwards, covering it is a whole number. And if you see, there's a difference. There's a zero with our natural numbers. So in the set of natural numbers, if you add zero before it, it becomes a set of whole numbers. And these all numbers are positive, right? But after that, there is always a need of negative numbers also. Do you know why? Why there's a need of negative numbers? Because like you have positive numbers, there are negative numbers too. Like in temperature, if you see, there are numbers which are beyond zero, right? So like in temperature, like the temperature of certain countries like Canada and all, they have, temperature sometimes it goes to -10, -20, even -40 also. So there are certain countries which has such severe conditions weather. So those negative numbers also exist. And also then below sea level, that also make our numbers as negative. So that means negative numbers also exist. So how we have then explained those number system where we have negative numbers and positive numbers, those are integers. So negative numbers on the left of zero and positive numbers on the right of zero. So these are integers. Then afterwards, you have done whole numbers, integers, natural numbers, then it comes rational numbers. That means how these numbers look like. If you see, there are certain examples which are given in this diagram. 0.9, and then there is a small bar on it. What does it mean? That 9 is repeating. So this is this kind of decimal. Then you have a fraction, mixed fraction, 1 whole 1/2. Then you have again a decimal. Then you have a minus. Now there is a fraction and it is negative also. So that means there are so many things which must be going in your mind. There are decimals, then you have fractions, then you have negative also. So all these numbers are rational numbers. But natural numbers are also rational numbers. Huh? Whole numbers are also rational numbers and integers. That means all of them are linked to rational number, all of them. But in the later slides, we will define what are rational numbers then. They look like this, they look like this, but what actually they are. Okay, so just have patience. We will move forward to the next flow chart, which will help you to move forward. So in grade 8, you are learning rational numbers. So simultaneously, you will learn that there are certain numbers which are not rational. So they are irrational numbers. And together, all of them comes under the family which is called real numbers. So real numbers is further divided into rational numbers and irrational number. And these numbers are not rational. So how these numbers look like? These numbers look like root 2, root 3, root 5, and so on. these numbers look different than our rational numbers, than integers, than fraction. That is why it is not a part of all of them. Rational number consist all. Rational number consist fraction, rational numbers consist integers, negative numbers, whole numbers, natural numbers, everything. So all of them are, but all of them are called real numbers. And this one alone is isolated one. Irrational number is also a real number. So that is also its family. But all of these numbers are different, yes. But so we have not defined it. So now if I ask you, you could have thought that decimals are also rational numbers, integers are also rational numbers, natural numbers are also rational numbers. So there should be some proper definition to it, right? So there is a definition to it. And we will understand then in decimals also how it look like. So all of you, I must say that you should have your notebook and pen ready with you. Wherever it is important, write it, okay? So that you always take note along with it and remember it. But you can come back again whenever you wish. You can come back again and see the video. So there, it is always there on YouTube. Okay, now we are going to define it. So that means rational numbers in mathematics, this is a proper definition, can be defined as any number, which can be represented in the form of P by Q. And this is very, very important. So they have given us P upon Q as numerator upon denominator. It can be A upon B. It could be X upon Y, anything, you can, any variable you can take. It is not necessary you take P upon Q. Where the denominator, Q should not be 0, because if something is 0, it is not defined. Okay, suppose if I say 3 upon 0, so which will not give you any number. This is not defined. So it is your first condition, okay, that your denominator should not be 0. It should always be a certain number. So when I say here 1 upon 2, it is a rational number. If I say 3 upon 4, this is a rational number. If I say minus 7 upon 2, this is also a rational number. Now Monica ma'am wrote minus 7 upon 2, what it is. And then 9 upon minus 5. This is also a rational number. That means there should be some difference between fractions and rational number. Do you know what are fractions? Fractions are also like in the form of 1 by 2, 3 by 4. Yeah, like these numbers. But both the numbers are positive. Numerator and denominator both are positive. Okay. So that means it is made up of whole numbers. And here also denominator should not be 0. But in rational numbers, it can be positive and it can be negative too, because all our numerator and denominator is made up of integers. Did you see a flow chart? It is making sense to you. If I go back, can you check that integers and fractions are making rational number? So your definition should come from here itself. That's the purpose of this number system. Fractions and integers together make rational numbers. So that means it should in that form, A upon B, P upon Q. And also your numerator and denominator should be negative numbers, positive numbers, which are integers. So that means our definition comes from here, if you see. So we have two types of rational numbers, one positive and one negative. I hope this is clear to all of you. And denominator should not be 0. Okay, so if somebody asks you what are rational numbers, so you can say they are integers as well as they are fractions. Now, when you have to define it properly, you will say that it should be represented in the form of P upon Q, where Q should not be equal to 0. Now, somebody asks you what is Q? It's a denominator, because if it is 0, it is not defined then in that case. I hope it is clear. So let's move on forward after that. Now, next part is properties of rational numbers. Now, this is something really, really important, because you are going to learn this, okay, today with me, and understand that what it means, all of them. So we will learn the properties of rational numbers under 4 basic operations. Now, what are operations? Addition, plus, subtraction, negative, then So multiplication, into sign, and division sign, right? So now there are certain properties which we need to study, that if it follows it or not, okay, under this operation. So we will verify each one of them. So today just see it. Okay, I hope that you are writing also and making notes for that. So the first one is our closure property. Now what is closure? So closure, if you see here, it says that under addition, A plus B. Now what is A and B? Any two number. Okay. So when we need to prove something, we will not take something necessarily a very higher number, because a positive number, simple natural number is also a rational number. So it will help you to understand very quickly. So addition means if I take 2 plus 1, okay, 2 plus 1, what it gives you? 3. Now, is 3 a rational number? Of course, it is a rational number. So if written, this symbol means belongs to, okay? So it means that A plus B belongs to rational number. It means that when you add two rational number, you get a rational number. So this is true. It is closed under addition. I hope that you're writing this. So when you have to prove that if closure property holds true under addition, you will say, yes, it is. When you add two rational number, now these two could be your negative, these two could be your fraction. You check with any of these numbers, which we have done. It is closed under addition. When you add two, you always get a rational number, either positive or negative. They are rational numbers. Now next, after that, A minus B belongs to rational number. When you subtract two rational number, you always get a rational number. Answer is yes, you always get it. When you multiply A into B, when you multiply two rational number, you will get a rational number. Answer is yes, you will get it. Okay, 2 into 1, 3 into 4, 1 by 2 into 1 by 3, which is 1 upon 6. Every time, whatever type of number you take, you will always get a rational number. Okay, but it does not hold true for division. It will not. And why is it so? Take any number, okay, and you prove A upon B. Does it belong to rational number? Answer will maybe, maybe not. So we will say does not belong to rational number. Sometimes it will come. Sometimes it will not come a rational number. So you will say maybe and maybe not. Okay. So when we have to write for a closure property, we will say it holds true under addition, subtraction, multiplication. Okay, not for division. Now the next part is our commutative property. Now the second, very important, because sometimes it will come in your exercise also, which property verifies this question, and you should remember it, that it is a commutative or not, and how to identify. Now between commutative and associative, there is a difference. Can you see in commutative there are two numbers? So commutative always deals with two numbers and associative deals with three numbers. So first, the very important part that you need to remember is this, okay? Commutative deals with two numbers and associative deals with three numbers. Now commutative, A plus B is equal to B plus A. What does it mean? If I change the order of those numbers, even then my answer remains the same. So if I say 2 plus 1 is equal to 1 plus 2, means the same. If you get here 2 plus 1, you get 3, and 1 plus 2 is also 3. If you change the order of your numbers, your answer remains the same. This will not change. So A plus B is equal to B plus C. So commutative property holds true for addition. So this is correct. For addition, it is okay. It is correct. Always it is. But for subtraction, does not hold true. Why? You can check 2 minus 1 and 1 minus 2. Do you think you will get the same answer? Check 2 minus 1 is 1. And 1 minus 2 is minus 1. Do you think 1 and minus 1 are same? No. 1 and minus 1 are different numbers. One is positive, one is negative. So commutative property does not hold true for subtraction. Okay. Now next check this one. A into B. Suppose if I say 2 into 1 is equal to 1 into 2. Do you think you will get the same answer on right side and left side? Yes, 2 into 1 is 2 and 1 into 2 is 2, which is equal. So it holds true for multiplication also, but not for division. 1 divided by 2 is not equal to 2 upon 1. So here for subtraction and division, it does not hold true. Okay, so remember, it's very easy and simple to understand. First, you need to understand in commutative, we always take two numbers. We always deal with two numbers in it. And then we see and verify. So for verify, you always have to take, a small number. You don't need to take big numbers and check that. So don't make it complicated. Take very small numbers. So I've taken 1 and 2. You can take some negative 1 or 2 or minus 1 or 0. Whatever you feel like, you can take it. So a plus b is equal to b plus a. So understand commutative property, it is always like this. Okay, always deals with the two numbers, and right side and left side should be same if you change the order of the numbers. So it holds true only for addition and multiplication, not for subtraction and division. I hope this is clear to all of you. Now next, start with associative. It is just like the commutative, but the difference is there are three numbers now. So a plus b plus c. So b plus c is, if you say here, this is one group, okay? And then a plus b becomes another group on the other side, plus c. So you can check this with three numbers. Suppose you take 1, 2, and 3. It should be as simple as that. So if I take 1 plus 2 plus 3, I make this one group, and then I make 1 plus 2, and then I make it as plus 3. So here you have 1 plus 5. 1 plus 5 become, so always you remember your BODMAS rule. Whatever is in bracket, you need to solve it first. Yeah. So that's why I am solving this 2 plus 3 together. So 1 plus 5, which becomes 6. And here 1 plus 2, which is 3 plus 3, which becomes 6 again. So did you see your right side and left side both are same? Okay. So understand here again that it holds true. Associative property holds true for addition, and similarly it holds true for multiplication. So here it holds true for addition and multiplication, but not hold true for subtraction and division, because you will get different answer in both on both the sides, and that's the answer. I hope you're clear with this. You do one more practice, it will go and fix it here. Okay, so don't worry. Now next, distributive property. So it is distributive, means you are distributing something. So distributive of multiplication over addition, a into b plus c. It is a into b plus a into c. This you're going to use it in many places, in higher classes also. I would say that you have done this in grade 7 also a lot, in if I say your perimeter of rectangle, that is twice of L plus V, what is that? It is nothing but distributive of multiplication over addition. Remember, you link any of the topics, the concepts of mathematics from one to the other. It is linked. That is also distribution you have done. And here the same is applicable for distribution of multiplication over subtraction, a into b minus is AB minus AC, but it does not applicable for multiplication division, because it will not make sense in it. Okay. Now next, identity. Now this I will help you. Identities in the next slide. Recap this and it will help you to solve your questions very easily. So now next, see the next one. So rule of zero is very, very important. And in this rule of zero, it is actually called additive identity. Okay. Additive identity. Zero is called additive identity. Zero. Now, what does it mean? Additive, there is a plus sign. Identity, now we have to check. Identity is that number when you add, you get the same number. Suppose if I say 1, what do I add to get 1? I have to add 0, right? What do I add with 3 to get 3? Means 0. So 0 is called additive identity. Remember, 0 is called additive identity. Very, very important. In rational numbers, in integers, while doing integers, you all have done the properties of integers also. 0 is called the additive identity. Identity means when you add something, you get the same number. And how will you get that? When you add 0 to it. So 1 plus 0, 1. 0 plus 3, 3. So in multiple choice questions, sometimes in your exam, your teacher gives you which one is additive identity or write the additive identity. You need to write 0 in it. Okay. Now next, role of 1. Now role of 1 is called multiplicative identity. So here I'm highlighting again down here, role of 1, which is multiplicative identity. Again, multiplicative means multiplication. And what do I multiply with 3 to get the same number? I have to add, I have to write 1. I have to multiply with 1 to get the same number. Suppose if I say 3 upon 4, what do I need to multiply to get the same 3 by 4? I have to multiply with 1. So 1 is called the multiplicative identity. Remember it again. 0 is called the additive identity and 1 is called the multiplicative identity. Remember it. Okay. So here, if I need to fill in the spaces, minus 2 over 7 into 1 is equal to this. So it could be 1 into minus 2 over 7 is equal to minus 2 over 7. So identity means you get the same thing, okay, when you multiply or add. And you only get when you have 0 and 1, right? Now for this, check the second one. Tell me, what should I multiply with 3 over 8 to get 3 by 8? Multiplying with 1. 1 is called the multiplicative identity. Remember it, okay? Fix it. Next, negative of a number. Okay, so it is just the opposite of a number, I would say. And here we remember it by additive inverse. Inverse means opposite. Okay, so if I say 6, its additive inverse is minus 6. Because when I add these two numbers, what do I get? 0. So our purpose is we should get 0. Okay, suppose if I say minus 7, what do you think? What do I add to get 0? I have to add plus 7. So plus 7 is the additive inverse. Now it's your turn. Okay. So if I say minus 3 over 4, what is the additive inverse of this number? Number remains the same, only sign changes. Okay. So minus 3 upon 4. So its opposite is 3 over 4. Okay. I hope this is clear. This is much more easier. Additive inverse. These are, something very, very important. It always comes in any school you are, whether you are in India, you are in UAE, you are in Singapore, in any part of the world, I want to say it. These questions are very important and it will help you in higher classes also. So just make yourself clear with all these properties. What is additive inverse? What is additive identity? Multiplicative inverse, multiplicative identity. Okay. So now one more. 1 over 3. What is the additive inverse of 1 over 3? Minus 1 over 3. Number remains the same, only the sign changes, the opposite of that number. The opposite of 6 is minus 6. Opposite of minus 7, plus 7. Opposite of 1 by 3, minus 1 by 3. Opposite of minus 3 by 4, plus 3 by 4. So remember it. It's very super easy for everyone to understand. Now next we have additive inverse. Now we have multiplicative inverse. Okay, so multiplicative inverse is also called as reciprocal. People called it as reciprocal. So both are synonyms, both have the same meaning, but understand. Now there, when I was doing additive inverse, when I was adding, I was getting the result as 0. And here when I multiply, I'll get as 1. So understand. So when I have 3, what do I multiply to get 1? Minus 3? No, I will not get 1. I should have 1 over 3. See, 1 over 3, when you cancel, you get 1 only. Yeah, so 1 by 3 is called the multiplicative inverse or reciprocal. Okay, let's take one more. If I have minus 2 over 7, what do I multiply to get it 1? You need to reverse. Minus 7 over 2. See? And minus minus become plus. You have to practice and you have to remember it. Sometimes additive inverse and multiplicative inverse becomes very confusing altogether when you do it. So It's your turn. Okay. So here, if I say take 7 upon minus 5. What is the multiplicative inverse of this number? Minus 5 over 7. Easy, right? So children, there are few things. What is the role of 0, role of 1, understand, and how you're going to use it in your questions. So today, when you do a good practice on it, whenever you say it, just do simultaneously few questions on your own. You can make on your own also, because the few questions are something you can make on reciprocal, additive inverse, and it becomes, your second nature to do such questions. Now let's move on to the next one after that. So we have now distributivity of multiplication over addition for rational numbers. Now this is something in the under that table we have done for properties of rational numbers. So let's see here. Take any three numbers. So I always take like the easy one. So suppose if I take -1, 2, and 3. Suppose let, assuming, so I say you write it as let. Okay, so you take these three numbers and try to put it in this way. So you have left side as well as right side. Okay, so whenever you prove it, you do like that. Then only you can understand. So A into B plus C. What is A for me? -1 into B. What is B for me? 2 plus 3. 2 plus 3 is 5 into -1, and it becomes -5. Now, next we have over here A into B. So -1 into 2 plus A into C, which is -1 into C, 3, which is -2 and plus of -3, which is again becomes, minus of 5. Do you see both answers are same? Yes. Left side is equal to right hand side. And then it verifies that distributive of multiplication over addition is verified. So how it will be? So you will see some questions like this also. Let's see another one. Okay. But before that, let's do a quick recap what you have learned. So if you have to ask me here, first question, what is the additive inverse of -7 over 19? Additive inverse means opposite number. It is 7 over 19. That's the answer. What is the additive inverse of 4? It is -4. So remember, numbers are same, only the sign changing. Okay. Multiplicative inverse of -7 over 19. It is 9. It is 19 over -7. Multiplicative inverse of 1 over 6, or you can say reciprocal, both are same. It is 6. Now next, multiplicative inverse of 7, 1 over 7. I hope this is clear. So all of you, my grade 8 students, or the children who are in grade 9, if you want to go back and recall few things, you can do anytime. So I wish all of you have understood today whatever we have done. So practice, which will make you perfect and confident and permanent in whatever you are learning. So I wish each one of you happy learning and keep practicing. Bye then, rise and shine, and see you again in my next video. Okay, and very soon. So signing off here, Monica Chauhan. Okay, bye.